All right, y'all. So number one, I'm going to start us out on math lab. And they're wanting us to graph y equals x cubed plus 2. So just remember, let me go to my paper here. So they're giving me y equals x cubed plus 2. If you remember on the basic graph, this would be the basic graph of the x cubes. The x cubes came up, went through the center, and then went uphill. That was our basic graph. So what we got to wonder is, what's that plus 2 doing to this basic graph? And y'all on that one, you just got to know, is that plus 2 going to move me up, down, left, or right? So it's going to shift it up. So this basic graph is going to intersect through here now, and it's going to come up, cross over there, and then go uphill. So it's just going to shift up twice. And if we looked at that on our graphing calculator, we can go to y equals, and we can punch in our x cubed, and then bring that exponent down and then do plus 2. So we can graph that, and we're expecting it. See, it just went up 2. It should go through the center as a basic graph, but that plus 2 pushed it up twice, okay? So on that, we're just going to pick a picture out of here. Looks like A did what we had, right? Looks like A went up. B looks like it went down and right. C looks like it went left. And D went up, but it also went right. So the only one we can pick on this, y'all, would be A, where it went up, okay? All right, y'all, look here. They're giving us the Fahrenheit temperature if we know the Celsius temperature, and that's given by the formula F of C equals 9/5 C plus 32. So they want to know what Fahrenheit temperature is equivalent to a negative 25 C. All right, so what I would do on that, and we're going to find F of negative 25. So that's 9/5 times negative 25 plus 32. At that point, you can punch this into your calculator and get an answer. Now, by hand, what I would do, when I multiply, I treat this one like a fraction when I multiply. And I reduce before I multiply. Because this negative 25 on top and this 5 on bottom, they will divide. And when you divide that negative 25 by 5, it gives you a negative 5. So this becomes 9 times negative 5, which is negative 45, plus my 32. And then negative 45 and 32 gives me a negative 13. But y'all, you could have punched it right in the calculator like it looks. So I could quit this screen. I have a fraction for the 9/5, so I'm going to do alpha y equals enter. Put the 9 on top. Put the 5 on bottom. I'm going to arrow right. Put in negative 25 for the C. And then that was plus 32. So either way you do it, when you hit enter, you get negative 13, okay? So we're just looking for negative 13 as one of our answers. And y'all, it's A there, so we click A, and then we move on. All right, I'll let y'all answer this one. Is this graph a function? Now remember, if the graph is a function, it's got to pass the vertical line test. Now y'all just did the horizontal line test for 1-to-1, but we're not looking to see if this is 1-to-1. We're going back and seeing if this can pass the vertical line test up and down. Now remember, for this to be a function, it can only be intersected by a vertical line once at any point. And if you run vertical lines up and down that graph, it is definitely only going to intersect it once on that. So what are y'all saying? Yes, yes. Good job. That is definitely, yes, a function. Any V-shaped graph is going to be a function, just like any parabola. Any of them basic graphs are functions, okay? All right, y'all. So that is definitely yes. And then we move to number 4. So now they want us to solve a system of equations. So y'all, let me write this down. 4x plus 3y plus a z equals negative 23. X minus 3y plus 2z equals 20. And then 11x minus 2y plus 3z equals negative 11. All right, so the question is, I worked these 2 different ways. I worked them by hand and I worked them by calculator. Does anybody want me to work this by hand? All right, so I'm assuming all of y'all are doing this one on the calculator. So let me share my calculator then. Now remember, on the calculator, I'm just going to put in the numbers and not the variables. Numbers only, and we'll go use our matrix on the calculator. So here we go. We're going to go to the calculator. Let me clear everything off so y'all can see how I'm doing this. So y'all, first we got to put the matrix into the calculator. So we hit second x negative 1 to bring up the matrix stuff. And then we're going to arrow right on edit and hit enter. Now, we got to know how many rows by columns. So y'all, what would I put into these 2 numbers where I got the 1 by 1 on my calculator? What would y'all put there? And let's think, how many rows we got? Well, we got 3 rows of equations. So you're going to put a 3 there. So that'll be a 3, enter. Oh, y'all got it. This is 3 by 4 because you got 4 columns. There you go. You got the X's column, the Y column, the Z column, and then the answers. All right, when you do that, it makes enough spots up here for my numbers. So I had 4x, so that'll be 4, enter. 3y, 3, enter. 1z, 1, enter. And then negative 23, enter. That's my first row. Then I got 1x, enter. Negative 3 for the y, enter. 2 for the z, enter. And then that row equaled 20, and enter. Then you got 11 x's. Negative 2y, 3z, and that row equaled negative 11, enter. So once you enter all your numbers on there, you're going to hit second mode so you can quit the screen. So we got our matrix in there. So remember, now we got to go get the math. So I hit second, x negative 1, and I'm going to arrow right to the math column, and then arrow down until we find RREF. Mine's always B on mine, B, RREF. Hit enter on that. It brings the RREF to the screen. Now you got to get the matrix. So second, x negative 1, and then enter because that's your matrix A. Once you got matrix A up there, you hit enter. And y'all, the right column, the negative 3, negative 5, 4, those are the answers in alphabetical order going from top to bottom. So we got a -3, -5, and a 4. All right, let me see what's my chat asking. How do I get the screen with the math menu? So once you've got the matrix put in there and you're ready to do the math, you're going to hit the second X-1 button on the left side. That brings up the names, math, and edit. Arrow right to math. And then once you get to the math, you just arrow down until you find RREF. Once you hit RREF, you hit enter, and that brings it on the screen. And then you do the second X-1 again and hit enter, because I've only put my matrices in the first slot, and that's where it got the 3x4. So just hit enter on that, and it brings it to the screen. So y'all, everything in that process focuses on the blue second button, and then 3 buttons below it, the X-1, okay? Alrighty, so we would go back to Math Lab. Now notice, they've already got the parentheses, so all you got to do is put in your 3 numbers. So I had a -3, a -5, and a 4. So your 3 numbers in there, and then move on. All right, y'all, so let me make this bigger. They want the domain, and the domain goes from the smallest x value to the largest x value. We're only looking at x values. We don't care nothing about the y values. So these 2 dots, I want to know the x value for the left dot, and then I want to know the x value for the right dot. So would y'all pick A, B, C, or D for that? All right, y'all, so let me see. If I go to this left dot over here and I go straight down, that left dot starts at -4. All right, Judy, it looks like B, right? Because that left side's -4. And if you go to the right dot and go to the x-axis, that one's at 4. So my domain is all the x's between -4 and 4. And y'all, that is B. So hit enter on that one. All right, y'all, let me write this down and then we'll graph these. So I got y greater than or equal to x plus 5. Y less than or equal to 5 minus x. So let me go to my calculator and show you how I would do this one. So I'm going to go to my y equals. I'm going to clear this out. My first equation was x plus 5. So y equaled x plus 5. It was greater than or equal. So remember, for greater than, I'm going to arrow left on the left side of the equals over here on the left side of the Y1 where that line's blinking, and I'm going to hit enter. And I'm going to hit enter until this is greater than. So I want this triangle blinking right now that's bigger on the top. So that's going to be my first equation. Then I'm going to come down here and put 5 minus x for the second equation. That was less than. So I'm going to go all the way left of the equals over here, left of the y2. And I'm going to hit enter until I get the triangle that's bigger on the bottom. So that one stands for less than. So now I hit graph. And I'm looking for the double shaded section. So if you see the double shaded section is the left half here, okay? So where you got the shading going up and down. It's that left corner on that one. Now y'all, I'm going to show y'all on the other calculator how to do this. Because the calculators are different on how you actually do it, okay? So on the CE calculators, you would put in your x plus 5 still. Now on them, they're a little different. Once you get all the way left of the Y1 and hit enter, it's going to ask you to color. Well, I don't care what color it is. So I'm going to arrow down to where it says line. And I'm going to arrow through the line until I get to one bigger on top. And then I'm going to go down and hit OK. Now I'm going to put in the second equation, which was 5 minus x. Arrow all the way left. This one was less than, so I'm going to hit enter. And come down the line and arrow right until I get the triangle bigger on the bottom. And then OK. The only difference is on this graph, you can see really easy where they're where they're overlapping. See that left side where you got the bluish, purplish tint, okay? So you're looking for the one that's shaded on the left side on MATLAB. Well, A is shaded on top, B is shaded to the right, C is shaded on the left side like we need, and then D was shaded below. So look for where you're getting your double shading at, okay? All right, here we got our ladder. So let's think. The foot of an extension ladder is 3 feet from a wall. Then it says the height of the ladder reaches on the wall and the length of the ladder are consecutive integers. They want us to find the length of the ladder, okay? So let's go play with that. All right, so let's draw this picture. We got a wall over here. I've got a ladder leaned up against the wall. And I know that the foot of this ladder is 3 feet from this wall. So I know this side is definitely 3 feet. Now, they said the height the ladder reached up on the wall here and the length of the ladder are consecutive integers. So that means if this was x, this ladder would be x plus 1. Consecutive integers. If this was 3, 3 plus 1 would make that 4. If this was 5, 5 plus 1 would make that 6. Consecutive integers are numbers right in a row. So if you don't know what those numbers are, you would use x for one number and then x plus 1 for the other number. That makes a 90-degree right triangle, which means we're using the Pythagorean theorem to solve this. And that was the a squared plus b squared equals c squared. Now, the c squared side always has to be your hypotenuse. The longest side is always c. This one can be a, that one can be b. So let's plug into our formula. A would be 3, so that'll be 3 squared, plus b is x, so that'll be x squared. That's going to equal c squared, which is x plus 1 squared. Y'all's formulas will look just like this other than the 3. Depending on whatever number you have here for this length, that's going to be the only difference between y'all's and mine. Because y'all will have the same consecutive integers like I do, okay? So everybody will look pretty much the same at that point. All right, y'all, so let's solve this. 3 squared is 9 plus x squared. That's going to equal x plus 1 squared. So on the side, if you got to, x plus 1 squared is x plus 1 times x plus 1. FOIL that, you get an x squared plus 1x plus 1x plus 1 times 1 is 1. Add the like terms, we get x squared plus 2x plus 1. We can now replace the right side with that. X squared plus 2x plus 1. All right, y'all. So at that point, we're going to start solving it. So first thing I would try to do, since I got all these x squared terms, I would try to get them on one side. So when I subtract this x squared to move it over here, well, y'all look what happens. This 9 comes down. These x squareds canceled, and that's going to equal, well, y'all, them x squareds cancel. If you got x squareds on both sides of the equations, they're basically going to cancel out. So all that's left over here is now 2x plus 1. At this point, y'all's will look exactly like this on the right side. Everybody should have a 2x plus 1 on the right side. The only number that's different will be the 9. So whatever number y'all had to square will be right here, okay? At this point, solving for x, I would subtract 1 from both sides. So I get 8 equals 2x, and then divide both sides by 2. So 4 equals my x. But y'all, they want to know how long is this ladder. They don't care about this side. This side is 4 because that was what x was. But the ladder is x plus 1. So that's going to be 4 plus 1, which gives us 5. 5 is the answer. We got to put in MathLab, okay? So I'm going to go back to the screen. And my ladder is 5 feet long. All right, y'all, what are they asking us here? State the domain. And notice they got them all in the interval notation. So let me write that down. F of x is a x squared plus 2x minus 15 over x squared minus 4x minus 21. Okay, so on the domain, all we're worried about is that the bottom of this fraction cannot equal 0 because that makes it undefined. So to solve it, I set the bottom equal to 0. And I'm going to solve this. So I'm actually going to factor it. X squared is an x and an x. Now y'all can use the quadratic formula, or you can graph this bottom one in your y equals member. If you graph it, you're looking for the x-intercepts where it crosses the x-axis to get the solutions, okay? All right, so by hand, remember, the last number is negative. You're going to have a positive and a negative in your factors, okay? Negative means unlike signs. Now, that minus also tells me to find factors of 21 that'll subtract and equal 4. So 21 is 1 and 21, 3 and 7. The only ones that'll subtract to give me 4 are 7 and 3. Now remember, since I got unlike signs, the bigger number 7 will be negative like the middle. So the larger number has the same sign as the middle, and then the smaller one would be my positive. All right, so now we're not done. We actually got to solve both of these by setting them equal to 0 to finish this. So here you would subtract 3. And on this one, you would add 7. Okay? And let me show you. If you're weak at factoring, like I said, go to your calculator. Let me clear everything off. So that's all cleared off, and I would put in the x squared minus 4x minus 21. So if you don't get the factor good, Here, just graph it like this. And look, on the left side, it's crossing at -3, which was one of my answers. And on the right side, that's 1, 2, 3, 4, 5, 6, 7, which was my other answer. So you can overcome factoring by graphing, okay? All right, so these two numbers I'm kicking out. So -infinity to -3, union -3 to +7, union +7 to infinity. You got a union around each number that you're kicking out, okay? And they got to be in order from left to right. All right, y'all, so we're looking for an answer that looks like that. So what do we get? -3 and 7. So it looks like I'm going with B. Um, Looks like they got the numbers back, the signs wrong on C for that one, okay? All right, y'all, then we would hit next. Okay, so here's one of the more tedious problems. They're giving you the difference quotient, f of x plus h, minus f of x all over h. Now, my function they're giving me, f of x equals 7x squared plus 9x plus 3. Alrighty, so this one is a definitely hand one here. Cannot do this one on our calculator, so we got f of x, which is the second part of the formula. We got to find f of x plus h so that we know what we can put here. And it's always got an h on the bottom, okay? So to find f of x plus h, we're going to put an x plus h here, and we're going to put an x plus h here. We're going to put these x plus h's in for the x's. So I got 7 times x plus h squared plus 9 times x plus h, and then I got a plus 3. Alrighty, so the first thing I'm going to do is figure out what x plus h squared equals. And y'all, x plus h squared, in the long run, we had these wrote down when we worked them out. But x plus h squared is x plus h times x plus h, which will give you a x squared plus hx. I'm just keeping mine in alphabetical order. Plus hx in the middle, plus h times h squared. Add the like terms and you get an x squared plus 2hx plus h squared. Save that because y'all are going to use the same thing as I did on that part right there. So bring down to 7. X plus h squared equaled this. X squared plus 2hx plus h squared. I'm bringing everything else down. So the only thing I did in that step was the x plus h squared became that. Now on this step, you're going to distribute the 7 through the first parentheses, distribute the 9 through the second one. So we're going to do all of our multiplying. So I get a 7x squared plus 7 times 2 is 14hx plus 7 times h squared is a 7h squared. That takes care of that one. Plus 9x plus 9h. And then at the end is a plus 3. So I'm looking to see if I have any like terms. And y'all, at this point, you shouldn't have any like terms on that. So this whole expression here is now f of x plus h. So here we go. F of x plus h, 7x squared plus 14hx plus 7h squared plus 9x plus 9h plus 3 minus f of x, which is 7x squared plus 9x plus 3 all over h. Now, I ain't gonna lie, what I do at this point, I'm going to cancel out these three factors with the three factors over here that match. So that 7x squared is being subtracted. It subtracts that one away. This 9x is being subtracted. It cancels with that positive 9x. This 3 is being subtracted. It cancels with the 3. So all that's left is 14hx plus 7h squared plus 9h all over h. So y'all, let me ask y'all this. What does this final answer simplify to? Let's see if y'all remember that. So one of y'all write me what this will simplify to, okay? All right, let's see what Justin got. 14x, okay, the h is canceled, giving me a 14x for that one. Good job. 7h, okay, that sounds good because you had two h's. One of them h's will cancel, leaving a 7h. Plus 9, good job, the h's cancel, and you're left with a 9. So you got to take one h away from everybody on the top when you're dividing by the h on the bottom. All right, so that's what MathLab wants. So let's go put that in. So that we actually had to write out, right? 14x plus 7h plus 9. So write that answer in and then hit next. All right, so the graph of a square root of 5 minus 4x. So y'all, the easiest way, let's go graph it. So this is g of x equals square root 5 minus 4x. All right, so I'm going to the calculator. I'm going to go y equals and clear that off. So square root is second, x squared button down here on the left side. And then I had 5 minus 4x. All right, so I just want to see the graph, so I'm going to hit graph. And look, it's a downhill graph, sort of curvy, and it stops right around after that 1 there. So I'm wanting one that matches that. So let's go to the paper. And y'all, oh, B was close, but B's on the left side of the y-axis. I needed the one like D. Look at D. D is on the right side like I needed. So be careful. Don't go too quick on these. Because see, if I make B bigger, you can see it's not even on the right side of the y-axis. It's got to be D on that one, okay? All right, so you're picking your graph, and next. Okay, so this is just a picture we're looking at. And we'll see what y'all pick, A, B, C, or D. They want to determine any maxima and minima. So that's the peak and the valley. So we want to see what this first dot, this little hump, that is a maximum value of 1 on the y-axis at the x equals 0. So let's see on our answers. A is wrong. It's either B or C, right? Relative maximum of 1 at x equals 0. Both of them got that right. So now we got to look at the valley here and see what the minimum is. That's a minimum of -3 on the y value at x equals 2. Justin, you got C, is that it? Um, yeah, I got 1 at x equals 0. And then that one had a relative minimum of -3 at x equals 2. Because the other one said it didn't have a minimum. But y'all, they got a big black dot on that minimum. So you're good on that one. It is definitely C for that one, okay? All right, now this one is nothing we got to graph. We just got to know what the moves are doing to it. So shifting it horizontally. So since they're looking at horizontally, they're looking at that -11 inside the parentheses. Remember, it's got to be inside the parentheses to move me left or right horizontally. So that -11, when I attack the x with that -11, is that moving me right or left? So since it's negative, it's actually going to move me to the right. Good job. So, well, the top three, A, B, and C, all say it's going to the right. So next question. What's that negative in the very front doing? The negative. Well, y'all, back then when we were doing these, if it had a negative in the very front, it was reflecting me across the x-axis. Only the x-axis at this point, okay? Actually, we never even reflected nothing across the y-axis. It was only the x-axis. So we went 11 units right, reflected across the x-axis. And y'all, the only one that's got those answers would be C. So let's see, it says shift it 1 unit up. Well, that if you add 1 to the end like that, it is going to shift me 1 unit up. Okay? So eliminate the ones that say reflect across the y-axis because those two answers are going to be wrong every time. It's got to be one of those with the x-axis, okay? All righty, y'all. So number 13, find the zeros. F of x equals 2x squared plus 9x plus 3. Well, unfortunately, you're not going to be able to factor this one. There's only one way you're going to solve this one, and that's with the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2 times a. On this problem, that's the only way you can solve it, okay? So you got to figure out a, b, and c. So a is the 2, B is the 9, and C is the 3. I'm plugging them into the formula now, okay? So it says x equals negative. Better write that negative every time. And then put in B, which is a 9. Plus or minus square root. B is 9 squared minus 4 times A, which is 2, C, which is 3. All of that'll be over 2 times my A, which is 2. So now we're just simplifying. Negative times a 9 makes that a -9. Plus or minus. Under my square root, let's see what I got. 9 squared is 9 times 9 is 81. Everything over here is being multiplied. So -4 times 2 is -8. -8 times 3 is -24. And y'all, that's all over 2 times 2, which is 4. All right, so one more step under the radical. So I got my -9 plus or minus square root. No, let's see. What is 81 minus 24? That is 57 all over 4. So to go any further, we would have to be able to simplify the square root of 57. So on the side, I got a square root of 57. So let's write our perfect squares. So 1, but that ain't helping. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 36, 49. What's next? 6 times, that was 7 times 7. 8 times 8 is 64. And that's bigger than that, so I can stop there. Is 57 divisible by any of these numbers? Yes or no? So I know it's not going to be divisible by any of the even numbers. And Jessamine, good job. This one does not simplify. Since that does not simplify, this is my final answer. You can only go further on this step if this square root simplifies. Mine did not, so I'm looking for that answer on MathLab, okay? So we got -9 plus or minus a square root of 57 over 4. Whoa, y'all be careful because B and D are close except for that bottom. I need D, -9 plus or minus square root of 57 over 4. So, woo, they got some close answers, but we got to pick the one that's right, okay? So that was D on that one. All righty, what I got? A vertex problem. Okay, let's see. Let me write that one down. That is f of x equals 4x squared plus 16x minus 2. Now, y'all notice these answers. A has got a, I'm going to find the x value first. A is -18, B is 18, C is -2, and D is 2. So if I can find the right x value, I ain't even got to do the y value because all the x's are different. Now, I will do the x and the y just to show you how to do them both, but um, y'all, that one can be done fairly quick. All right, Justin's saying a -2 on that, and so let's see. Vertex formula, -b over 2a, and then f of a -b over 2a. So we're going to get the x value by doing -b over 2a. So that's negative. Okay, let's see. A is 4, B is 16, C is a -2. So that's going to be a negative times 16 over 2 times my 4. And y'all get -16 over 8, which is -2. So Jasmine, good job. -2 on that. Now, if you wanted to find the y value, you would be finding f of -2. That means put a -2 in for the x's. All right, so let's see what we get. -2 squared is +4. 4 times 4 is 16. 16 times -2 is a -32. And then I got a -2. So y'all, 16 minus 32 is a -16. -16 minus 2 is a -18. So Jasmine, we should be finding a -2, -18. But like I said, that would be C. So C, the only right one, once you got that -2, you could have been done. You could have done the Y value, but like I said, they all got different X values. So you wouldn't even have to put that much work into it, okay? All right, let's play with this. A -4x squared, x minus 7, x plus 1 cubed. So they just want me to find the zeros and the multiplicity of each. So remember, the exponents are the multiplicities. Hey, there's not an exponent after this x minus 7. What exponent would I write right here technically? All right, good job, yes, and that's a 1 right there. So that means the multiplicity of this factor will be a 1. So multiplicity 2, multiplicity 1, multiplicity 3. Now to set the factors equal to 0. And then that one was an x minus 7. And then that was an x plus 1. Well, y'all, this one, I divide both sides by -4. I still get x equals 0. Anytime you have single x's out here like this, I don't care if there's a number in front of them or not. If they're not having stuff subtracting and adding, and it's just a single term like this, that x will always be 0. This one here, I'm going to add 7, get x equals 7. Here, I'm going to subtract 1, get x is a -1. So x equals 0 has a multiplicity 2. X equals 7 came from this factor, has a multiplicity 1. And then -1 came from this factor, and it has multiplicity of 3. So you solve the little variables. Once you got them solved, those are the zeros, and then the exponents are your multiplicity. All right, y'all, so we need something looking like that, okay? All right, so my -1 had a multiplicity of 3, so it's either A, B, or C. The first three have -1, right? Multiplicity 3. Then they're going to, this one has 0, multiplicity 2. That's what I had. And 7, multiplicity 1. So it's going to be A. Because B, they said 7 had a multiplicity of 1, but they didn't get the 0 here, okay? And then C started out good. It even started out good with the 0 multiplicity 2. And then somewhere they got us 1. Well, we didn't have a 1 at all for the zeros. And that one had 1, 2, 3. That one had too many zeros. And then D was wrong. So the only one that could be right would be A on that one, okay? All right, y'all, this one, let me write this one, because this one I'm just going to graph it. You got an x plus 2, x minus 2, and an x plus 4. Now notice the window. This graph goes from -10 to 10 on the x's, but it goes from -70 to 70 on the y values. And the y values look like they're going by 10. Looks like that. Looks like 10, 20, 30, 40, 50, 60, 70. So they're going by tens. So I'm going to graph this and see what I get. Now, y'all look at this. A and C are really close. A has more on the left side of the Y. C has more of it on the right side of the Y. Usually when they give you two graphs that are similar, it's usually one of them two graphs. So let's see if that's true here. So I'm going to go to my Y equals. I'm going to clear everything. So that was an X, and in parentheses, X plus 2. Next parentheses, X minus 2. And in my last parentheses, X plus 4. All right, I got everything down. I'm going to go to my window. So the X's went from -10 to 10. They're good. That Y minimum, though, was -70. And then the Y maximum was a +70. And the Y's, I'm going to make them go by 10. Anytime your Y values are in the 70, 80, 90, 100 range. You want the scale to be 10 on those, okay? All right, y'all, let me hit graph. So look at that. Most of my graph is on the left side of the y-axis. It's crossing at -2 and -4 on the x-axis on the left side. And on the right side, it's crossing at +2. So I want one that was shifted more to the left. So if I look at my graphs, y'all, A was shifted more to the graph. I got that -2, -4. Yeah, so it's got to be A. C was too much to the right, okay? All right, y'all find the vertical asymptotes. You got an x squared plus 2x minus 8 over x squared minus 5x minus 14. All right, two ways to do this. I'm going to factor it. This is one of those where you could graph the bottom in y equals and see where the x-intercepts are, okay? Um, but I'm just going to set the bottom equal to 0 because remember, vertical asymptotes, we find those the same way we do the domain. Vertical asymptotes occur where this is undefined. And the only thing going to make it undefined is if that bottom equals 0. So we force it to give it the answers by setting it equal to 0, okay? All right, y'all, x squared is an x and an x. The last number is negative. So one's positive, one's negative. All right, y'all, let's find factors of 14. That's the only two ways to get a 14. One of those will subtract and give me 5. That's going to be 7 and 2. The larger number has the same sign as the middle, so the 7 is going to be negative. The 2 is positive. All right, finish this out by setting those equal to 0. So here, subtract 2. I get x is a -2. On this one, I would add 7. And x is a +7. Notice, these are x's. They're not y values. They're x's. So when you pick the answer, you want a -2 and 7, which is what C is. But y'all, B has the right numbers, but it's got the wrong variable. The y variable went with the horizontal asymptotes, not the vertical. Okay? So be very careful there that you pick the one with the x's. I always have people missing that. They go too quick and they pick the one with the y value sometimes, okay? Oh, y'all, this is stuff y'all did on your test this week. They got f of x equals 3x minus 4. G of x equals 3x squared minus 2x plus 2. They want me to find G compose f of 4. All right, y'all, so I'm doing this one by hand. So remember, G compose f of 4 is really like G of f of 4. So we got to find f of 4 first by putting the 4 in for this x. That's going to give me a number. Once I get that number, I'm going to put it into the x's for the g, okay? So the first thing, f of 4. So that's going to be 3 times 4 for the x minus 4. All right, y'all, 3 times 4 is 12. And then 12 minus 4 gives me 8. So since f of 4 was 8, we're now going to find g of 8. So that 8 comes up here and goes into my g equation, which is 3 times x, which is 8 squared, minus 2 times x, which is 8, plus 2. All right, y'all, so let's see. 3 comes down. Only thing I'm doing is the 8 squared. 8 times 8 is 64. All right, y'all, so let me see what 64 times 3 equals. That's going to give me 192 minus 2 times 8 is 16 plus 2. So 192 minus 16 plus 2 gives me a final answer of 178. And y'all, this is what we want on Math Lab, okay? So did that have answers? Oh, that's got 4 answers. Okay, so A, B. We want D, 178. Okay? So not bad. Just do, they got the order there. G compose F of 4 means that F goes first, then to G, okay? Now this one is sort of the same, but they didn't give us any numbers for this one. I got 4x squared plus 5x plus 4 for my F. G of x is just a 5x minus 6. They want me to find G compose F of X. All right, y'all, so I'm going to get one of them 4 expressions when I'm done. All right, so let me move stuff out of my way real quick. All right, so this one is like G of F of X. But they didn't give me a number here. So I can't put a number into this. So what I'm going to do is take f of x and put it into the g. I'm going to take this f of x here and put it into that 1x for my g. Okay? So that means we'll have 5 times x. Well, x is this whole expression. So that's my 5 times x, and then I got a minus 6 at the end. So remember, the whole function for f goes into g, okay? All right, so to start this, distribute 5. 5 times 4 is 20x squared. 5 times 5 is 25x. 5 times 4 is 20. And then you got a minus 6 at the end. And y'all look at that, like terms. So 20x squared plus 25x. 20 minus 6 is what's that? Positive 14. There you go. All right, y'all. So that's what we're looking for on that one. So 20x squared. So it's either B or C. 25x. They both got that. Oh, look what they did. I want B, but C, instead of subtracting the 6, it looks like they added the 6. So be careful, okay? And look at all 3 terms of those to make sure. All right, y'all, they want me to find the inverse. F of x equals a cube root of x plus 7. All righty, so inverses was from yesterday on that test. So they want me to find the inverse. The first thing I'm going to do is change f of x into a y. I'm going to switch the x and y. So switch those so that you get x equals a cube root of y plus 7. Now you're going to solve that for the y. Now here's the difference on some of these. This plus 7 is not under that cube root. So since the 7 is not under the cube root, your first move is to subtract 7. So you're going to get an x minus 7 over here equals a cube root of y. Now, to undo a cube root, you would raise it to the third power. So I'm going to raise the x minus 7 to the third power. That's going to equal the cube root of y to the third power. So this cube root will cancel with that exponent, leaving your y over there. And y'all, let's see. Ain't nothing we can do to that. So that's just going to stay x minus 7 to the third. Now the last step is to change y to f inverse of x notation. And that's going to equal to x minus 7 cubed, okay? So to undo cube roots, we cube them. So y'all, we're looking like that answer for one of them. So I had a, whoa, be careful. A has x cubed minus 7, which is close, but it's not right. We wanted the one that looks like D, x minus 7 cubed, okay? All right, y'all, at that point, next. All right, so this one, we just got to graph it on a calculator. Now look at these graphs. They go from -6 to 6 everywhere. So I'm going to set my window to match their graphs. Okay? But I'll tell you what, that -3, when I tack the x's member, if I subtract 3, it's going to move it to the right. Well, A graph went down. B graph looks like it went left. C graph maybe went right. And then D, I don't know what they did to that one. But let's graph this on the calculator, and I'll set my window from -6 to 6. All right, so let me go back. I didn't get my expression. That was 2 to the x minus 3. So 2 exponent. And if you want it in parentheses, you can do x minus 3 in parentheses like that. The window was -6 to 6. And I'm going to go by ones on those. -6 to 6 on the y values. And I'll go by 1 on those. So the SCL is just a scale. How many numbers do you want each tick mark to represent? So those were all going by 1, it looked like. So y'all would hit graph. And look, it is the one that looked like it went right, like we said. So we want to pick the one that looked like C. See how C sort of went to the right like the graph did, okay? All right, y'all, that is the LN 3A equals 2.2. All right, change this to exponential. So remember, they're doing the stuff where I had the log base A of y equaled x if and only if a to the x equals y. They're giving me the logarithmic side. I got to convert it to the exponential. But y'all, here's my question for y'all. I don't have a base by this LN. So what is the base for a LN going to be? Oh, not a 1, y'all. Watch this. Remember, I said an ln was really a log base what? Now, this one, just a log like this is a log base 10, okay? If it's just a log like that, that would be a log base 10. But y'all, we don't have a log. We got an ln. So what is the ln, member, is the log base E. Remember, that's the one that has the log base E for Euler's number. This is the natural log. So remember, it's really a log base E. So if you wanted to rewrite this, it would be a log base E of 3 to the A equals 2.2. Now you can convert it because I got my base here, A, which is E. So that's going to be E. My exponent is X. Well, X was the result. So that's going to be the 2.2. And that's going to equal Y. Well, Y was the result. And that's the 3A. Okay, so remember, your base of the logarithm is the same as the base of the log, which was E. The exponent is equal to X, which is the exponent of the log, 2.2, and that equals Y, and Y was the number after the log. Okay? So y'all keep this conversion because that's what I'm doing on those every time, okay? And just remember that an ln is really a log base E on those, okay? All right, y'all. So one of those should have had an E 2.2 equals 3 to the A. Now let me look at those real good. Is it C? E to the 2.2 equals 3 to the A. There you go. All right, y'all, let me see what I got. A log base B, a fourth root of an x9 B3 over Y4 Z16. All right, so they're giving me the four answers at least. So really the trick on this one is to write this without the radical. So I'm going to put my x9 B3 over my y4 z16 in parentheses. Now, this fourth root, if I wrote it as a fractional exponent, would be a 1/4. So that was just converting the radical. Now you got to multiply every exponent inside those parentheses times 1/4. So for the x, 9 times 1/4 is 9/4. For the b, 3 times 1/4 is 3/4. For the y, 4 times 1/4 is 1. For the z, 16 times 1/4 is 4. So what I do, you take the 9 divided by 4. Couldn't do nothing to it. 3 divided by 4, couldn't do nothing to it. 4 divided by 4 left me 1. I don't have to write the 1, remember. And then 16 divided by 4 was 4. All right, so this, now, if they're on top, they're going to be positive. The factors on bottom will be subtracted. And I'm going to distribute log B to every factor, okay? So I got a log B of x to the 9/4 plus a log B of B to the 3/4. These two are on bottom. They're getting subtracted. Minus a log B of y minus a log B of z to the 4th. Now, This one, I'm going to bring the exponent down. The y don't have an exponent. This one, I'm going to bring the exponent down. But right here, you got log base b of b to the 3/4. We had a little property that said if the log base matches the base raised to an exponent, the exponent is the answer. This property applies right here. You got a log b of b to the 3/4. This whole thing is going to equal 3/4. So bringing this exponent down, you got 9/4 log b of x. Plus this one became 3/4 minus log b of y minus, bring the 4 down, 4 log b of z. All the exponents that brought down, this got converted, so there is nothing else I can do to that. So y'all, that is my final answer. Whew, so let's pray we got one like that, right? So 9/4 log b of x. They all got that. Plus 3/4. Well, looks like B and C at this point. D says times 3/4. That's wrong. So it's B or D now. Minus log B of y. Well, boy, they both got a log B of y. And then look at the end is minus 4 log B of z. B, they got plus 4 log B of z. So we're going with C. 9/4 log b of x plus 3/4 minus log b of y minus 4 log b of z. Also, this one's not bad. They give you a formula on this one. They're giving you b equals 2 million e to the 0.05 t. So this is the population of a small country. Sort of goes back with what we did yesterday. Monday with the 9.7. The only difference is we're giving you a formula and we want to know how many people the country will have after 3 years. So basically, you're just going to put a 3 in for the t and solve this. So we're going to be finding b equals 2 million e to the 0.05 times my t, which is 3 years. So y'all, let's punch that on the calculator. So Jessen, is that B for this one? Let me punch it in and see what you got. So 2,000,000,000,000. And then E with an exponent, I'm going to hit second LN to get that E. That's 0.05 times 3 years. So Amani, see what it is. So let me see, what did they want us to round to? Looks like we're rounding to the nearest year or the nearest person. So, whoops, I want my calculator. So that's a 0.4, so I'm going to leave that at 8. So that's going to be 2,323,668. So 2,323,668. So if that 4 after the decimal would have been bigger, like a 5, 6, 7, 8, or 9, I'd have made that 8 a 9, okay? All right, so perfect. Y'all said C, so that'll be good. All right, so definitely C on that one, okay? 668 on that. Now remember, if the population is increasing, it's got to be more than 2 million. So there's no way it could be A, okay? Oh, y'all, look, this is our last question. We got 4 to the x equals 21. And they're giving me 4 answers. So let's see what we get. So A is rounded 2 decimal places. The other 3 got 3 decimal places. So somehow we should get something similar to those, okay? Exponential equation. First thing I would ask myself, can I rewrite each side of these using the same base of a 4? So no, I cannot change the 21. 4 times 4 is 16, times 4 is 64. No way to do that, okay? So we cannot rewrite it. So that means I'm going to take a log of both sides. So the log of 4 to the x will equal the log of 21. Now the reason we took a log is because of the power rule. I can now bring that x down to the front. So I can bring my x to the front and I get x times a log of 4 equals a log of 21. All right, y'all, last step, divide both sides by log 4. Now just remember, close these parentheses on these logs. So x will be approximately whatever we get out of these, okay? So I'm going to go to the calculator. I'm going to clear everything off. I'm going to make mine look like a fraction, so I'm going to hit the green alpha button, y equals enter. So on top was a log 21, close parentheses. Arrow down to the bottom, you got a log 4, close parentheses. All right, Amanda, we're going to see if it is a 2.196. And that looks good because that answer only had it rounded 3 places. So that's got to be it, right? 2.196. And y'all, is that on there? That is definitely on there. Oh, you look at that. Didn't it submit? So, ooh, that was 25 already. So we submit it and you're done with it, okay? Oh, y'all, I might have room on here. All right, y'all. So for y'all, what y'all want to do? Make sure you do the module review, the final exam review. That counts as a quiz grade, member. And then you got your final exams. The final exam is now open, okay? Final exam is open now. It is due Thursday at midnight. And y'all, that's tomorrow, June 26th. So you got today and tomorrow till midnight to knock out this final exam and any other work that you need to catch up on with, okay? Y'all, after midnight tomorrow night, you're going to lose access to Math Lab. You will not be able to work anything else. The final exam has a 2-hour time limit, so make sure you start by 10 p.m. on Thursday for sure. Okay? And Monty, yeah, you can take everything today. I got it all opened up for y'all, okay?